Friends, in today's class we are going to discuss about the chapter units and dimensions. This is a very important chapter of your 11th syllabus. Let us discuss this. Now, whenever we discuss about the quantities, if I say that what are physical quantities? So, what will be your answer when I ask that what are physical quantities? Physical quantities. Physical quantities. Do remember that quantities which can be measured are said to be physical quantities. Quantities which can be measured are said to be physical quantities. Now, if I ask you that what can you measure, आप क्या क्या measure कर सकते हैं? So you can say that you can measure mass, you can measure length, you can measure time, you can measure temperature, you can measure current, you can measure speed. So all these quantities which you can measure is actually physical. These quantities are physical quantities. But there are so many quantities which you can't measure. So these are the non-physical quantities. For example, can you measure honesty? Certainly not. You can't say that someone is 2 kg honest. Why? Because it is not a measurable quantity, and that's why it is not a physical quantity. So what are physical quantities? The quantities which can be, these are the quantities which can be measured. Now these physical quantities are of actually two types: independent physical quantities and dependent physical quantities. Now what are independent physical quantities? See, independent, as the word suggests, independent means that the measurement of these physical quantities does not depend on other physical quantities. Okay, so these quantities are called fundamental physical quantities or independent physical quantities. Independent physical quantities are those physical quantities, their measurement does not depend on other physical quantities. For example, there are actually 7 fundamental physical quantities. I am writing these fundamental physical quantities as length, length, time, current, which is electric current, electric current, luminous intensity, luminous intensity, luminous intensity, amount of substance, amount of substance, amount of substance, mass, length, time, electric current, luminous intensity, amount of substance. 1, 2, 3, 4, 5, 6. And last is temperature. 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 Now, what is the unit of mass? See, unit of mass is kg. Okay, it can be gram also, it can be milligram also, but SI unit, SI, International System of Units. In International System of Units, the unit of mass is kg. In International System of Units, unit of length is meter. In SI, unit of time is second. Unit of electric current is ampere. Unit of luminous intensity is candela. Okay, unit of amount of substance is mole, and temperature is Kelvin. Okay, so these are 7 fundamental physical quantities, and these are its units. As I told you that there are independent physical quantities, similarly there are some dependent physical quantities. Okay, dependent, as the name suggests, that these quantities depend on the fundamental physical quantities, they are dependent. So measurement of these quantities, dependent physical quantities, depend on the fundamental physical quantities. Okay, so let us see the examples of it. Dependent physical quantities. Dependent physical quantities are those quantities, their measurement depends on the fundamental physical quantities. Okay, so if we take the example of dependent physical quantity, so basic example, let us take area. If you say area of, if you say rectangle, simplest one is rectangle, so the formula is length into breadth. Okay, now length is, you know that length is length, we are representing it by capital L, and breadth is also length only. Okay, basically it is a length only. So you can write it L into L. Okay, now you can write it in square bracket like this, and you can write it as M0 L2 T to the power 0. Now we are writing this area, okay, and that is in square bracket, and we are writing it in this form. This is called dimensional formula of area. What it is called? Dimensional formula. Dimensional formula. Now this dimensional formula, it gives so many information. It gives the information that M0, it means that area doesn't depend on mass. T0, it means that area doesn't depend on time. L to the power 2, it means that area depends on length, and that is 2. Second power of the length. Okay, and this is what is called dimensional formula. Okay, this is the dimensional formula. Okay, now these powers which are represented here, these powers are called dimensions. We call these powers as dimensions. So these are dimensions. Okay, they are dimensions. Is this thing clear to you? Next, let us take the example of volume. Volume is a dependent physical quantity, and it is simplest one is cube or cuboid. So length into breadth into height, and that gives you L into L because breadth is also length and height is also length. So that gives you L to the power 3, which can be written as M0 L3 T to the power 0. So this is the dimensional formula of volume. So many such quantities are there which are dependent physical quantities, like let us take speed. Now speed is given by formula of speed is distance upon time. Now what is distance? Length of the actual path. So this is nothing but L1 and time is T1. So this gives you M0 L1 T to the power minus 1. And from here you get one more information that the speed, it depends on length and time, but it doesn't depend on mass. Okay. Similarly, if you write velocity, so you know that velocity's formula is displacement upon time. Displacement is also length. So you will be getting the same dimensional formula for velocity as you got it for speed. Same dimensional formula is there. Okay. Next, let us take acceleration. If you take acceleration as a dimensional formula, if you take that, let us see now next physical quantity, dependent physical quantity, acceleration, denoted by A, written in square bracket to represent its dimensional formula. Change in velocity upon time is the formula of acceleration. Change in velocity. Velocity or change in velocity, both will have same dimension. अगर आप किसी लेंथ में से लेंथ को सब्ट्रैक्ट करते हैं तो भी डायमेंशन तो लेंथ का ही रहता है. इसी तरह अगर वेलोसिटी में चेंज करोगे तो डायमेंशन तो वेलोसिटी का ही रहेगा. सो वेलोसिटी का डायमेंशन हमने अभी देखा था वो स्पीड का डायमेंशन जैसा है, तो हमने वहां लिख दिया m0 l1 t to the power minus 1 divided by time is t1, so that we have written. Now you have m0 l1 t to the power minus 2. Okay, so this is the dimensional formula of acceleration. Okay, next is force. Now what is force? Force is mass into acceleration. So mass, what is the formula of mass? Mass dimensional formula is m1 multiplied by acceleration l1 t to the power minus 2. So that gives you m1 l1 t to the power minus 2. Okay, next is work. You know that the formula of work is force into displacement. Force is given by m1 l1 t to the power minus 2 multiplied by the displacement, that is length, that is l1. So that gives you m1 l2 t to the power minus 2. Do remember that whatever the dimensional formula of work is there, that is the same dimensional formula for energy also. Energy and work both are same things. Energy is work, work is energy. As we say that energy is the ability of an object to do work. Okay, so energy is work, work is energy, so both have the same. Energy is work, work is energy, so that's why energy and work both have the same dimensional formula, that is m1 l2 t to the power minus 2. Do remember that any energy you take, potential, gravitation, whatever it is, always the dimensional formula would be this only. Okay, now, dimensional analysis has some great applications. So now we are going to discuss some applications of dimensional analysis. Okay, so the first application of dimensional analysis which we are going to study is, first application is to check the validity to check validity validity of a of an equation, to check the validity of an equation. So how can we check the validity of an equation? Okay, so suppose we have an equation. This is the equation of time period of a simple pendulum, which is given by t equals to 2 pi root L by g. Okay, where capital T is the time period of oscillation, L is the length, and g is acceleration due to gravity. T is time period, T is time period, L is length, which is also called effective length actually. Small g is acceleration due to gravity, acceleration due to gravity. Okay. Now you have to find the dimensional validity of this equation. So for that, what you will do remember that an equation must be dimensionally as well as numerically correct. अगर वो डायमेंशनली करेक्ट है लेकिन न्यूमेरिकली करेक्ट नहीं है तो वो इक्वेशन एक्चुअली वैलिड नहीं है, और अगर कोई इक्वेशन न्यूमेरिकली करेक्ट है पर डायमेंशनली करेक्ट नहीं है तो वो भी वैलिड नहीं है. सो वो दोनों होना चाहिए, तभी वो एक फिजिकल एक्सप्रेशन बन पाता है, फिजिकल इक्वेशन बन पाता है. तो यहां पर जब आप डायमेंशनल करेक्टनेस की बात करते हैं तो आपको करना क्या है, आपको एलएचएस और आरएचएस के डायमेंशंस फाइंड करना है और देखना है कि क्या वो दोनों डायमेंशंस इक्वल आ रहे हैं. अगर दोनों डायमेंशंस इक्वल आते हैं तो आप कहेंगे कि वो डायमेंशनली ये जो इक्वेशन है वो वैलिड है. तो सबसे पहले आप एक काम कीजिए, सभी के डायमेंशनल फार्मूलाज लिख दीजिए. टाइम पीरियड का डायमेंशनल फार्मूला हो जाएगा m0 l0 t टू द पावर 1, क्योंकि ये टाइम है, टाइम पीरियड मतलब टाइम, तो उसका डायमेंशन t1 रहेगा. लेंथ l, तो लेंथ का डायमेंशन हो जाएगा m0 l1 t टू द पावर 0. एक्सेलरेशन ड्यू टू ग्रेविटी स्मॉल g, और इसका डायमेंशन हो जाएगा m0 l1 t टू द पावर -2, m0 l1 t to the power -2. So these are the quantities. Let us write the dimension of LHS, left hand side, LHS. So dimension is of dimension of time period, so that gives you m0 l0 t to the power 1. Okay, next is, let us find the dimension of RHS. Now when you are finding the dimension of RHS, you see 2 pi is actually a constant and it is dimensionless, and because it is dimensionless, it has no dimension, you don't need to write dimensions of it. Length has the dimension m0 l1 t0. Okay, and because it is square root of it, so we can okay, we will do one thing, we will be doing it like this. Here we have written the dimension of length upon small g is acceleration due to gravity. So that gives you m0 l1 t to the power -2. Okay, m0 l1 t to the power -2. Now its power is 1 by 2. So that gives you m0 l0 t to the power 2 to the power 1 by 2. Now here you will get m0 l0 t to the power 1. Okay, because this 2 into 1 by 2 will give you 1. Now you see both the sides have the same dimensions. LHS and RHS have same dimensions, and if they have same dimensions, this equation is dimensionally correct. So this is what the dimensional validity of the equation. Okay, like this you can check the validity of another equation. if you have given another equation, say equation of motion, you must have studied equation of motion in 9th standard. So let the equation of motion is v equals to u plus at, and now what you have to do is you have to check the dimensional validity of this equation. So you know this here that v is the here final velocity, u is initial velocity, a is acceleration, and t is time. So let us write the dimensions of all these quantities. V is velocity, so it has the dimension m0 l1 t to the power minus 1. U is the initial velocity, doesn't matter which velocity it is, velocity will have the same dimension. So U is m0 l1 t to the power minus 1. Acceleration has the dimension, that is m0 l1 t to the power minus 2, and time has the dimension, it is m0 l0 t to the power 1. Okay, let us substitute the values. Now left hand side of the equation, if you take the left hand side LHS, so dimension of V will give you m0 l1 t to the power minus 1. Okay, this is the left hand side. Now let us do it for RHS, right hand side of the equation. When you are doing it for RHS, now you have U, which is the initial velocity, which has the dimension m0 l1 t to the power minus 1, plus acceleration has the dimension m0 l1 t to the power minus 2 multiplied by t to the power 1. Now if you solve it further, you will be getting m0 l1 t to the power minus 1 plus m0 l1 minus 2 plus 1 will give you minus 1. So here you can see that these two quantities have the same dimensions. If they have the same dimensions and they are added, do remember that after adding these two quantities, you will be getting the same quantity only. ऐसा मैं क्यों कह रहा हूँ? अच्छा बताइए आप कि अगर आप लेंथ में लेंथ को ऐड करते हैं तो क्या आपको वॉल्यूम मिल जाता है? नहीं, लेंथ में लेंथ को ऐड करने पर लेंथ ही मिलता है। इसलिए अगर एक डायमेंशन वाली क्वांटिटी में उसी डायमेंशन वाली क्वांटिटी को ऐड किया जाएगा तो भाई डायमेंशन तो सेम रहेगा, इसलिए n0 l1 t to the power minus 1 आएगा। एंड this is what the dimensional correctness, you can see both the LHS and RHS have the same dimension, and that's why the equation is dimensionally correct. Okay, now some work for you people. Second equation of motion you will be doing yourself. S is equals to UT plus half AT square, and the third equation of motion also, V square equals to U square plus twice AS. These two you will be solving yourself and checking the validity of the equations. This is what your assignment is. I hope it is clear to you. Thank you.